Hey everyone, my name is Harry Tormey. I'm the CTO of StepChange.work. We're a consultancy that focuses on making your databases and apps faster. Today I'm going to be talking to Luke Van Setters. He is the co-founder of Novi.ai. They're a consultancy that focuses on discovering and building AI applications. And today Luke is going to be talking to us about an awesome project that he just completed and shipped called Zelma. So Luke, over to you.
Yeah, thanks so much, Harry. Yeah, super excited to be on this podcast. Yeah, so Zelma. Zelma's a project that we did with a woman named Emily Oster. She's an economist at Brown. She's a best-selling author in parenting. She has one of the most popular Substacks, which is on parenting as well. I'm helping a friend at a hackathon coming up, and one of the organizers. I mentioned that I worked with Emily Oster, one of the organizers, and she said, I'm pregnant right now, and Emily Oster is basically my god, was her phrasing of it. So her team does a ton of work to assemble a bunch of data as well. And so during COVID, for example, she assembled a bunch of data sets around school closures. And so as part of her research, she was curious to see how school closures and different approaches to virtual schooling affected students' performance. And so in the US, every year students grades 3 to 8 take statewide standardized tests. These tests are different in every state. So Alaska has some, and South Carolina might have totally different ones. And this data is technically public to be able to see the results in aggregate of how students are performing in these states, but it's really tedious to get. Tedious in the way of, for some states, she had to call a bunch of different people to eventually, 6 people later get mailed a USB of some of this data. And so her team basically painstakingly went through the process of getting every single state, standardizing the data itself, to then be able to share it. And her intention was that this data is really valuable for economists doing research, or researchers in general, but it's also interesting to the average person, because it deals with things like how different districts might be, districts or schools that might be preferable to send your child to, or trying to understand how school funding is allocated. Some school funding is tied to performance on these tests. And so she had this giant data set, was ready to publish it, and was like, it's sort of unsatisfying. This is only accessible to data literate people, SQL literate people. And so she went to OpenAI, who's a partner of ours, who then funneled her to us to figure out how we could make this a little bit more accessible using AI.
OpenAI put Emily in contact with you guys. What was the first thing you did to get this kind of consultancy ball rolling? Tell me about that, Luke.
Yeah. Yeah, so I mean, one of our kind of general mode at Novi is that we like to move really quickly. We pretty much as soon as possible want to get something tangible we can see and play with, so that we can really start to get a sense of the problem, what's going to be easy and what's going to be difficult. And so within the first 24 hours or so, she had sent us some data as part of this ask. We pulled that data down. It's from Alaska. And the next morning basically had a simple version where we could ask a question like, show me math scores over time, for Alaska, and it would graph. It was using Python to generate like a static PNG line graph over time, that attempted to answer the question, based on some SQL that was generated from a language model. And so we also had this kind of crumb. I think you'll share some screenshots to be able to show this. I'll send those your way, but we had this crumb of an expression, of like a public feed as well, where you could see past queries that people had run, with the idea being that there's something interesting to be done if you can see other people's the other questions that people are asking of the system and react to them basically.
I think it's really important for people who are thinking about doing consultancy, about how you actually explain to the client, hey, this is what we can do, right? Like this is, where we're at today. How do you want to iterate on this? And I think that's one of the fascinating things about your approaches. We do this more with assessments of code bases and looking at like basically, the telemetry from databases. But I think for people who are trying to do consultancy with AI, it's really fascinating to look at like basically the 24-hour version versus the months of work, and this got shipped to the public version. So I'll try and include both those screenshots there. So you showed this to Emily and her team. What was the initial reaction to that, and how did you kind of distill, this initial call into a larger roadmap of things that need to be built out?
Yeah, I mean, I think that part of it is just giving something to react to, and so we had something to react to there, and so we realized, LMs can definitely do SQL really well. They're trained on a lot of code. We showed them the first thing, and they were like, "This is amazing." but the results are actually totally wrong. Like the graphs that it produced and the aggregates that it was doing were actually not right, and not right in not in the sense that the it was aggregating incorrectly in a sense or computing wrong. It was that this data set has a bunch of different sort of, I won't say warts about it, but particularities of how you have to query it in order for it to be accurate. So for example, they have the data partitioned by gender, where they'll have entries for man and woman, or they might have it by ethnicity, and then they might have the same people counted again in this different partitioning of it. So you have to always select a partition of the data. They also have different granularities, state level, school level, etc. And so when you don't query it with that knowledge, it produces results that multi-aggregate the same people over.
Well,
So
can you
that
give a
was important.
specific example of something where this would screw up and would be noticeable to maybe someone who's not as technical, like who's,
Yeah,
just a lay person who's kind of coming to this trying to type in a query and it's like, what the hell is this? Talk me through that.
you might say, like, for example, how many schools took standardized or were proficient in math in Alaska in 2019, let's say, really specific question. You would get back, if you did not filter by the right data level, um, the number of schools times three, because the school might appear at the school level, it might appear at the district level, and it might appear at the actual state aggregate level. So there's all this sort of um, yeah, I think it's denormalized basically data, or it's duplicated data really across the data set to make it easier to query, but also harder to query in some sense too.
When you got this feedback, how long did it take you to solve that?
Yeah, so the correctness was a big part of it, and then another big part of it was just the speed. We found that to do these queries, there's a lot of large aggregates that you're grouping over, and so it would take 30 to 40 seconds for some of these larger queries to
Wow.
complete, which is maybe fine on the order of going and telling a research assistant to go get you some data. 30, 40 seconds, not so bad, but for a tool that you're using, we have different product expectations as users generally. So yeah, so that was our big focus at the start, was how do we go and solve both this correctness issue and the speed issue. Yeah, so we started with correctness, and with the idea being that before we make it fast, we better make it right, so we don't make it fast and wrong. And so uh, writing arbitrary SQL, we found, just allowed for too much freedom. So we knew that these would ultimately mostly be shown as a visual. So we had some sort of grounding that we're going to select columns that are going to appear as a line graph, a bar graph, pie chart, these sorts of different visual supports. Um, and so we created a data structure, just basically a big JSON schema that encoded these assumptions we already had. Another assumption being that you need to select at a data level, or you need to select which partition of the data you're going to be by, gender, ethnicity, etc. And so those constraints then allowed the LM to basically fill in this JSON object. And so we used function calling, or tool calling, as it's called now, to basically achieve what's possible with the JSON mode that they have now, where we ask the LLM, hey, here's a user's query, here's a schema of a table, basically fill in this JSON structure that we had. Sure that we always had the constraints filled, and we got something that satisfied a visual.
And so, was there gaps in the data? Because I'd imagine, if you're stitching together all of these USB thumb drives, CSVs, and stuff like that, like maybe for certain types of query, it was missing stuff. And, how did you deal with that if there was gaps?
Yeah, so I guess at least at the SQL level, we weren't super concerned about the gaps. I'll get into a little bit about sort of encouraging people to use the data correctly. Maybe uh, maybe in sort of like maybe after finishing this thought on speed, I would say.
Hmm.
But because it is really important, because there are a ton
Ah,
of gaps in that data. But once we had it, that we had this structure, basically, it would generate a SQL query that was ultimately going to be valid to run against it. You might just get no results, and be displayed no results, which we want to try to avoid, but was sort of okay from a UX perspective. Um, the bigger thing from there was saying, we have this structured object. Now, how do we make it actually fast?
hmm.
So, because it's still on the order of this 30 to 40 seconds, even though it is right at least. Um, and so the way we thought about that was, off the bat, we were able to, we realized that the visual component and sort of the filtering component, which state are we talking about, what subject are we talking about, are somewhat decoupled. I can say I want proficiency rate over time by grade, and then I can say for Alaska and math. So we basically broke those two pieces apart and ran them in parallel as two different calls to the LLM. And then after the fact, we sought to basically use a bunch of methods to make the output itself a lot smaller. So an important thing when you're building with LLMs, any sort of LLM product, is that the speed, the latency of your output from an LLM is directly proportional. It's basically linearly proportional to the length of your output, because for each the LLM internally is functioning by outputting a single token, tacking it onto the input, chugging it through again, asking for another token, this auto-regressive motion. And so if you have 10 tokens, that will be 10 times longer than a single token. And so we did a lot of tricks. We were looking at the tokenizer. There's a OpenAI has a tokenizer page where you can see how many tokens are in a given output. We were choosing names, for example, all caps enums are 2 tokens generally. But if
Wow.
you lowercase it, that's a single token because the word is more likely to occur in lowercase. Little things like that, which are sort of particulars that you wish you didn't have to deal with LLMs, but in practice make a really huge difference. So we could get multiple orders of magnitude more, or not orders of magnitude, but maybe one order of magnitude faster speed wise just by those token swaps and reorganizing the
Did
data.
you at a certain point like add in observability or any evals to kind of just say, hey, we've got this prompt that's optimizing for basically a lot less tokens in the response, and we can kind of measure across these different queries that this is actually getting better for all this sort of stuff, or like what was your approach there?
Yeah, so so we did at some point. So one of the things that we did was um, we wanted to help guide the models. There were a lot of cases where there were maybe a couple interpretations of how to answer a question. So I'm trying to think of a good example. One was how does this school district compare to the rest of districts in math over time? And so you could think of a couple different things. I could either show you an aggregate of both and show you their comparison. We have this idea of an achievement gap, which shows the difference. So I could show you a delta graph. We generally wanted to see both as opposed to this delta. And our model out the gate preferred to show this delta because difference, it's thinking, subtract. I get it, I get it, GPT-4, I get it. But we wanted to guide it. And so there were a lot of cases like this where we wanted to provide sort of hints to the model. And so we had a RAG-based approach where we would index known good queries and then, given a user query, find other ones that were similar, pull those in, and then try to generate. And so, sort of getting to your point of around observability and such, that was a major point where we had a lot of control and wanted observability to be able to debug cases that the model wasn't doing well. So we used Ragas, which is a RAG specific eval framework, and we've used it a few times now. It's pretty good, and it measures a bunch of different criteria around how, for different example cases, did you even pull the right context? And if you had the right context, are you generating appropriately from it to sort of decouple the pieces of the problem of generating accurately from RAG?
This is really good stuff, Luke. For anyone who's watching this, I mean, Ragas is really great, like way for doing evaluations. It's great to have something like that if you're building an LLM application. Now, I want to just dig in a little bit on one thing that you said, which is known good queries. So it sounds like there might be some opportunity for caching, which I assume is great because you don't have to spend money on queries. Because if you're asking about like, Alaska, performance in math in 2019, that's not going to change. Like once you've calculated that result, you can kind of like basically serve that up again. Was there much opportunity for caching? Like, what did you mean by that? I'd like to learn a little bit more about it.
Yeah, I mean, we do caching in the way of I would say it's a very hard caching. It's really materialized because once you have a user's query, we're computing SQL out of that, and then the SQL itself is never going to change. So we'll still update, and we regularly still. I think there's a banner on the website right now if you go that says there's new data that's coming soon. So the data itself can update, but the SQL will stay static because it's still, you know, yeah, it's the same query ultimately that's being run against new data. Yep.
Mhm. And so the known good queries, was that basically like cache hits, or did you do some kind of like proximity thing? Like, it's like, hey, this query is kind of close to that. Like, what was that?
Mm. Yeah, so we embed actually. Yeah, this is a bit of an interesting piece to this. So we embed we use embeddings. We have a vector store. We use Pgvec as just a tack. We're already using Postgres, and so it's an easy tack on. This is talking about the known good queries. There's only about 1,000, on the order of 1,000, let's say. So pretty fast to scan over that as a vector index. And so we take the user's input, vectorize it, and then compare it against the vector of other user queries to see which ones are most similar and rank them. Now, one challenge with this that we found is, um, and this is a challenge for embeddings in general. I think a lot of people take embeddings off the shelf, like the OpenAI ones, and sort of treat them as a catch-all, universally good embedding. Embeddings ultimately are about sort of compression. It's about saying these two things, which are very different, puppy and dog, are actually quite similar. So can we map them onto entities which are themselves quite similar? But in our case, for example, when I say graph math scores over time for Alaska and graph math scores over time for Georgia, or graph um, Alaska, show me the top 10 schools best in Alaska, there's a problem here because you can think what's more similar, the ones which are both about Alaska or the ones which are almost the same except for the state is different. And the embeddings, sort of will arbitrarily pick, right, which of these matter. For us, we know clearly we would rather have the one which, sort of blanks out the state. But you could imagine, but what happens in practice is that the embeddings put the Alaskan ones closer together than the Alaska and Georgia, which are almost the same phrasing. Um,
And how did you solve that? Like, what kind of ranking did you do with the stuff that you were getting back from the vector DB?
Yeah, so the way that we solved it was that actually Lizzie and our team worked on this. She took the user's input query. She basically took these queries and normalized them, templatized them. So on the input, we have a fine-tuned 3.5 model which reads, math scores over time in Alaska and turns it into placeholder subject scores over time in state. And then we index the best examples in the same, so the best case examples in the same way, and then we vectorize those. So basically, we remove these things which we know we want to become sort of variable. We care a lot more about the
Ah,
structure basically than the literal state choice and the math choice, etc.
that's
Right?
that's a really clever way to pre-process and, still be able to leverage the semantic similarity. That's really cool. Just might be a good time to kind of take a step back and talk about like what AI stack or application stack you use to build Zelma.
Yeah. So yeah, and some, I mean, reflecting on some changes that we would make, we're on GCP. We're using Kubernetes. So we have a Python backend, which is hosted in Kubernetes. We also use Celery in Python for background tasks. And then we have a front end, which is Next.js hosted in Vercel. And the rough lifespan of a query is um, we have someone enters a query in the UI that goes to our Python API, which creates a record in Postgres. So Postgres stores both all of our sort of user-facing data and all of this 100 million rows of test score results as well. And I'll kind of get back to that, but we basically will queue it. So we'll immediately create a record marked as pending. You'll get kicked to a page which says pending. I'm thinking about your data, computing your thing. That gets put on Redis, which goes to our Celery workers. The Celery workers actually do the LLM call and compute it. In the case that there's like a failure, that'll auto retry itself until it resolves. And the front end will pull for a status on that query until it is able to render it basically
And that's
once
pretty
it
cool.
completes.
And are you using Fast API for your Python APIs?
Yep. Yes, we have Fast API for the Python APIs. Um, and yeah, and I think just to finish the thought, like why I hesitate is that we've had to do a lot of manual indexing, I'll say, of that Postgres database, up to 100 million rows. And I've dealt with this a couple times in the past with really large Postgres databases, but we've, for example, for future projects that are really data intensive, we've been big fans of ClickHouse since. So would definitely maybe that's something you can help us with actually is we got to
Yeah, we
migrate that data out to ClickHouse at some point.
Yeah, that's one of the things that like Step Change does is they help with basically complex migrations and performance issues with at scale Postgres, but we also work with MongoDB and of course ClickHouse. But kind of, before we delve into the sort of like why you'd want to migrate off of things, you gave me some figures before we did this interview about like how much you cut down the latency. So talk to me about that. Like, what was it like in the 24-hour turnaround demo versus the actual production one? Like, how much did you reduce the kind of like latency of the actual query?
Yeah, so in the end of doing all those optimizations, splitting apart the visual and the filter components, reducing down their token usage, and uh, yeah, and a few more optimizations. We got it from around 30 to 40 seconds down to around 5 seconds, sub five
Wow.
seconds, pretty consistently. Yep.
That's
Yep.
really, really, really cool.
Well, I'll also say that this actually, I'm remembering now, is before GPT-4 Turbo as well. So that was another huge adversary of ours. Is we tried with 3.5, it wasn't accurate enough for us to just swap it in. So yes, we're dealing with super slow. So now that we have Turbo on it, it's even faster than that, right?
And I
But that
gotta
was a
ask,
huge.
have you guys tried 4.0 yet? The new one that's come out that's supposedly super fast?
We haven't for Zelma yet. We have for some of our other projects, and it is super fast. There's another project that we worked on, Paid Leave AI, which you can check out. It allows for people to chat with a chatbot to help get access to paid leave through their state, assuming their state offers it. And that uses 4.0 now. And we were just looking at a demo this morning. It is super fast. It's unbelievable.
Wow, what kind of latency reductions are you seeing with paid leave?
I think it's around the reported 2x, I would say.
So
Yeah,
as
and it's
advertised.
as advertised, yeah. Yeah. So I don't hold me to that. I don't have the hard numbers. This is a vibe-based metric. It seems twice as fast. But like I would say it's I if you help me, that's my best guess, yeah.
Well, so, just before we move on, did you optimize for any other figures? Like, were you monitoring like costs or anything like that?
Yeah, so cost for us wasn't a huge issue. I'd say
Hmm.
cost was generally low enough around the queries. The part where cost got really challenging is that as part of helping users figure out what to query, we built an autocomplete out. And the autocomplete includes basically an LLM that actually generates it's two multiple LLM calls on each type, basically.
Wow.
And so that was really expensive initially. And so we swapped that out for two fine-tuned 3.5 models, and that brought costs down a lot. But yeah, actually just suggesting to users things to say ended up being the most expensive component.
Dude, that's pretty incredible. And do you have any kind of just stats, like in terms of uniques or views, just so people listening to this can frame the amount of traffic that Zelma is getting?
Yeah, I mean, we're it's sort of a niche audience who's really excited about this data, but we're up to around I think a few hundred. We've got like 100,000, over 100,000 unique views, on the order of tens of thousands of unique visitors as well. So, which is pretty good usage for education data app for an education data app. Yeah.
Well, that's really cool. Look, and I think you alluded to this a little bit earlier, but like, do you have any database war stories from your time, building and launching Zelma?
Yeah, I think I do indeed. So, um, yeah, so when we launched, so like I said, Emily has really significant blog presence, and so she shared this out through her blog initially, and that led to a big flood of traffic of people who were really excited to check out Zelma when we launched, and pretty much immediately we started seeing latency in the app itself until the app was totally just frozen. You would go to load this page of all of the feed of everything people were doing, and it would just be nothing. And of course, I had been up, late testing it, trying out different things, all this stuff. And so I'm sort of exhausted coming into the launch, really excited. We're finally there. And then, yeah, database, we track it down. Turns out database pegged 100% CPU right off the bat. And I'm like, all right, we do what we got to do. And so, follows sort of standard protocol rather than trying to figure out too much what's going on. It's like, let's just embiggen it. Something is clearly inefficient. Let's just embiggen it. So took it from, I think it was like, it was pretty small. It was like maybe 4 gigs of RAM up to 16 gigs of RAM, 100% pegged again. Took it from 16 gigs of RAM up to, and more vCPUs, et cetera, et cetera, up to like 64. Now we're at like 90%. And both of these have caused downtime too, which is, so it's like, we know that we're going to cause like another like 3 minutes of downtime with each of these upgrades. We have finally up to like 64 gigs of RAM, like maybe 16 vCPUs, something like that. The thing gets to 90%. And so we threw on performance monitoring, threw on slow logs, threw on a bunch of kind of like Postgres observability pieces. And we realized that there's a lot of text searching that people do for school names, districts, counties. And we had indexed, we'd used, was it the GIN index to tokenize and index text. We had done it for the district and the school, but not for the county. And it turned out, for whatever reason, that user base was very excited to ask about counties. And so there were a bunch of these queries on the homepage, and we don't actually cache the results of the database query. So we cache the LLM generation of the SQL, but not the results themselves. It's a future improvement potentially. But so every page load from every person was hitting us with this county query, which ends up being a scan over the 100 million rows, of text of a text search, which is also a wild card both sides includes. So it's on case sense, super inefficient thing to scan over. So we added that, and immediately the usage dropped to sub 1% after that
Wow.
index was started on. And then
Damn.
a couple more index tweaks that we found from there to be able to scale it back down. But
How long
yeah.
did it take you from, because I know you had this like launch and it just totally just spiked the database and took down the site. How long did it take you to get that under control and figure out that like it was this missing index that was causing the problem?
Yeah, I mean, yeah, which is funny because that actually required no downtime, right? We just need to add that index. Um, and also we did a vacuum analyze. That's another one, another good Postgres trick. Remember to vacuum.
So tell
You
us
know,
about that before you,
yeah,
um,
sure. So yeah, maybe yeah before, so vacuum. Basically, Postgres doesn't immediately delete records or clean up indices. Basically, if you add a huge amount of data, and so we had re-indexed a huge amount of, we had just re-added a huge amount of our data to these indices, and then there's a background process of vacuuming, analyzing, which rebuilds and cleans up, rebuilds the indices and cleans up rows. But that happens on some cadence. You might know, you would know better maybe what that default cadence is. Um, but whatever it was, it had not run since our last index, which was, sub 12 hours ago, before bed sort of thing of trying to make sure all the data was perfect for launch. And so that was another huge cut down in the CPU after we were able to bring the thing back down,
okay. And so how
CPU
long did it
usage.
take you to actually find the missing index though from launch?
Probably was about 45 minutes, I would say, of downtime, which is
Hmm.
tough because that was like that's that initial impression moment. If you go and the site's down, you're not really going to necessarily check back later. That's your moment. Um, so yeah, I would have loved for that to be faster for sure.
Well, and we got to move back to the ClickHouse thing because I think people are going to be fascinated by this. But so why do you think ClickHouse would have been a better fit than Postgres?
Yeah, well, one main reason is that for the most part, we're selecting three columns of a data set that's rather wide in terms of the amount of data it has. So it's maybe, I think, on the order of maybe, let's say 20, 30 fields per row. And so Postgres is a row-based database, ClickHouse is a columnar-based database. And so already you're massively cutting down on the amount of data that you're fetching just on selecting a subset of columns, filtering over a subset of columns to be able to produce that result. It's also just out the gate sort of structured to be able to handle these sorts of analytics queries, as opposed to Postgres, which is OLTP database. It's meant to be transactional based row level, not these like giant aggregates. You can tweak it. You can add plugins and things to make it a little bit more apt, but yeah, ClickHouse out the gate. Probably we wouldn't have to do nearly any of these indices and there's a ton of indices on that because we're not writing data really ever. We're mostly just reading. And so we went heavy on the number of indices that table has to make everything as fast as possible. But that's also bigger on the storage side. So a lot of downsides to using Postgres, which is just not an OLAP database, not like an analytics query database.
I know on some of your projects you have worked with Pgvector. I think Zelma is Pgvector, and you've used standalone vector DBs. How do you feel about those? Like, using Pgvector versus using Quadrant or Pinecone. Tell me Luke's take on all of that.
Yeah, sure. So I would say so Pinecone's really expensive. That's I guess like the issue with them. No shade, it works well, but yeah, it's pretty expensive. Mostly we already have data that's located in Postgres for the most part. So it's easy to tack on pgvec and use the same system for migrations, and have it also co-located with other data that you're filtering on. So in our case, for example, we at one point were using a different set of examples. This is, I think, a good example. And in most vector databases, you can store some degree of metadata
Hmm.
alongside the actual vectors. So, same with Qdrant. But usually that metadata is data you already have in your own database. And so just having it co-located alongside is super easy. Um, the thing with Pgvec, and I haven't really encountered this much myself, so I'm definitely not an expert in this, but you have to, at some scale, you have to start optimizing it. Ultimately, every vector database, there's not the differentiation is really just how easy is it probably to run and how cheap is it to run, because they're all approximating the same idea, which is like bulk cosine similarity. It's just like massive cosine similarity to fetch most similar results. And at some scale, you can't literally scan and check every single one. You have to do some sort of clustering or partitioning or something, which is an approximation. And there's different strategies for how you approximate that. So yeah, just to finish on QGrant too, like, so we use QGrant in cases where we do need to do a large amount of vector search. So I believe we use QGrant for paid leave, the project I mentioned before, where we're indexing a ton of government documents, where we're breaking them up into chunks. We're actually massaging them with an LLM before indexing, but we have thousands and thousands of records and potential pieces of information that we pull in there. So for that, we use QGrant as just kind of a more easily optimized out of the box vector solution that is self-hosted as well. So
Mm.
it solves the
That
cost issue.
that's really fascinating that you've worked with a bunch of these different things and have that perspective. In terms of Pgvector for this project, do you want to? Is there any configuration details or stuff that you can share about how you're using it, like
Yeah, so
indexing strategies and stuff like that?
yeah, so it's I can share it's not that exciting, which is that we're not really doing much of anything. We're because we only have 1,000 examples. The scan over all examples is really fast, and that's
Hmm.
really like a quintessential example of when it's not really it's probably not worth it to support another library or another vector instance to then join over whatever the heck you might do with it from there. Just having pgvec and literally scanning over that whole table is so fast that it's not worth optimizing basically. So generally we'll reach for pgvec as a first choice for that reason, that it's very easy to just add to an existing Postgres database, which is generally our transactional database choice. And the scan is pretty fast until you get to, I don't know, tens of thousands, hundreds of thousands of records, right?
That's fascinating, Luke. So, okay, if you were doing this again today, right? Like, let's say someone was coming and they're like, hey, we want to do something similar to Zalma. We love the work that you did there. Is there any kind of technical things that you would do differently apart from maybe use Clubhouse? Sorry, not Clubhouse, ClickHouse. Anything that you would do differently from a technical perspective?
Let's think. Yeah, I mean, so we're planning to deploy Zelma-esque services. A lot of people have a need around being able to query their data with natural language, and so it's something that we're thinking about as we're deploying in the future. Um, One thing, so definitely ClickHouse, definitely an OLAP database for the actual uh, uh, data, or a Snowflake or Redshift, something similar to be able to query the huge amount of data. No question about that. And in most cases, we would want to plug into like a company's data lake anyways, so it's in a good place probably to start. Um, the only other change that I might make is from a latency perspective. So these models have already gotten a lot faster. The other thing that's challenging about using actually a closed source model. So open source models have gotten a lot better. And one of the things that's challenging about using a closed source model is that when you're generating these structures, these like JSON structures like we do, you also you can say generate according to the schema, and it's going to generate by saying bracket, name of the key, and then the value you want. But maybe the brackets, the quotes, all there's a lot of characters that it ends up generating when you do a single query to a large LLM that are sort of statically known. Like we know we're going to open with the bracket. We know that after the closing quote on a string value, we're going to have a comma because we know there's another key. All those sorts of things. And so when you're doing a single pull of data from like a large LLM, you have to let it generate the entire structure, including things that you know that you're going to always generate. For example, a bar graph will always have X, Y, Z keys, or those sorts of things. But when you use an open model, you don't have to do that. So with an open model, you can do you can do these partial generations. There's a lot of good libraries for this. One's called Guidance, which we've used for other clients, or Outlines, where you can do guided generations. And the idea is you say, um, open brace, key name, colon, start generation, and then only generate up until the closing, a comma, let's say if it's a numerical value, then skip ahead, generate just a string append the next key, and then start generating at the next field. And so you can basically skip the structure of JSON to be able to uh, generate, and that's a 2 to 3x speed up.
That's a
Right.
really cool tip. Where do you host these open models? Because, like, OpenAI, Anthropic with Claude, it's pretty awesome. They have a really nice API that you just pay per use. With the
Mm-hmm.
open models, like, where are you hosting these, Luke?
Yeah, again, really depends. So like for that sort of access, I'll be honest, I don't think we have a good hosted version that also gives that level of like LLM access to it.
Yeah.
Um, One of them is so we've hosted LLMs on we use SkyPilot is so you can that will basically work over any cloud provider, GCP, AWS, etc. to deploy models onto GPUs. I think it plugs into Kubernetes as well. So we've hosted Llama on that for some folks. Um, Together is also really great in terms of having access to an open model just to try it out because it's a lot to spin up a GPU cluster and all those sorts of things. But also even just locally, like for just playing around with some of these things to get a sense of whether they work well, you can pull down these models and try it
Well, yeah,
yourself.
that's kind of because that's what I was going to ask you about was like, obviously Llama is great. Like you can host it somewhere, but do those hosting providers give you that level of access to do the partial thing? And like, is this
Nah.
just something that you're like fooling around locally, or is there like, are you hosting this on-prem or on, I don't
Yeah,
know,
yeah.
or Amazon or like, what, how do you actually basically use that in production environment, that partial generation technique?
Yeah, so we're not doing it yet, probably soon. But you can, I believe, Outlines, for example, has support for VLLM, and SkyPilot also can deploy things as VLLM containers. So I believe that all hooks up to be able to do this sort of partial generation
This
on a
is
GPU
this is a
cluster.
great blog post for you guys and a great feature request for feature. I'm sure there's about like a ton of AI startups that are looking at this to just be like, yeah, I want to talk to Luke about this. This sounds like a
Oh
good
yeah,
idea.
I'm a huge fan of this sort of like partial generation. I wish that I think it'll become more popular probably because it is an easy way to get 3x speed up, and it's not only just the speed up of generating these intermediate tokens for something like a JSON structure. You can do full constrained grammars like regex in the output. So you can say pick a number which is 0 to 10, and it could never pick 20 because you're actually taking the output probabilities of the transformer and you're limiting to only the output tokens next that would fulfill the grammar and such. So you're guaranteed to have an output. You can do it with like enums, um, yeah, all sorts of really cool strategies and stuff you can do.
Dude, this is really great stuff. I mean, and just to kind of like plug the Novi.ai blog, Luke, I believe, and the team is going to be publishing a technical blog post going into like some of the details here. So I apologize if I was a bad host and like I didn't get all of this out there, but there's only so many minutes in an hour, and like but don't worry, like when that comes out, I will link to that in the stepchange.work blog so that you can go and read all the awesome stuff that Luke and the team has been doing. Um, Kind of a question that I have, going back to, your use of Ragas. What are you actually putting in basically your evals? Like what kind of things are you storing there? Can you tell us a little bit about that?
Yeah, so for the evals there, we have a sense. So we manually basically created a collection of known good. Like I said, we already actually have this collection of known good examples that we're using to correct model mistakes. So it actually doubles as a really good test set that we can then pull down and use as well. That we happen to build up progressively by being like, oh, the model did this, can it do this instead? Yeah, sure, add an example. And so, over months we got that data set. Um, what we're putting into it, I mean, it's basically that. So we have that data set where it might be a query like math scores over time in Alaska, and then it's the output structure that we want, that JSON, the two pieces of the JSON structure that we ultimately want to produce. And then when we're using Ragas for that, we will say, here's this question, here's the examples that we would have fetched based on the retrieval through the vectors, through Pgvec and embedding it and such. We take those and then we say, given and there's different metrics. I forget the exact names, things like correctness versus I forget. They have a few metrics that they define, but basically that separation where it could be that I'm not retrieving sufficient examples to get a good response, or it could be that given perfect examples, I'm still not able to generate something which is perfect, and so it's able to decouple those. But yeah, so those are basically the three components we get.
And that's awesome piece of information, Luke, about how you're using it. Did you look at other evaluation frameworks? Because I noticed recently there's been quite a lot of them.
So we have to go back, I think, and take a look, because at the time, and even actually, this was our first exploration into Ragas as well. Before we were writing our own evaluation frameworks for the most part, because just what people are publishing about in papers or on Twitter and stuff was well ahead of where the libraries were. And a lot of libraries, and this is true of I think a lot of LLM libraries still, is adopting them is more work than it is to just build your own. And a lot of it's like LLMs aren't really that crazy of a concept ultimately in terms of software, right? You're outputting something, you're putting in something in some inputs, you're getting back an output, and you're working with that. Especially when we can do these sort of typed outputs, that's just a function. I don't need a special library to deal with a function necessarily, but evals is a great case where we probably want more standardization, and so Ragas, great example of that. But no, I mean I have to try some more. Do you have some that you like?
We kind of like, the stuff that we're doing for our internal co-pilots, we didn't see really good evaluation frameworks for code. And then, we need to be SOC 2 compliant and be able to go on-prem for some of our customers are really sensitive about that kind of stuff. So we weren't really super blown away with a lot of the things that were out there because they were more focused on, hey, I'm trying to do a RAG pipeline for basically a Q&A bot or something like that. It was very text focused. So we ended up going with the roll your own version. Although we did look at Ragas, and I think it's a really good choice if you are doing a certain type of thing, which is kind of a little bit different from database migrations and automating, analyzing code bases and stuff like that, and making sure that the pipelines produce the same stuff on a consistent basis. Well, Luke, I just want to say thank you so much for sharing all of your, insights about Zalma. And yeah, if people want to hire Novi.ai to kind of build their awesome AI application, what's the best way to reach you guys?
Yeah, you can reach out to me directly. I'm Luke at Novi.ai. And you can reach out with questions or anything from coming out of this podcast as well. Or you can reach out to us at hello at Novi.ai, which is sort of our main way to get to everyone on the team.
Awesome. Thank you so much, Luke, for taking the time to talk to me.